Hello guys, welcome to another video of QOTD, Photography and Mathematics. And we will be continuing on matrices today. Not really specifically matrices, we're going to talk about more, but then they are all related to matrices. And first of all, as you probably have seen from today's title, we're going to talk about transformations. And what are the 4 transformations we've learned in IGCSE? I'll give you 5 seconds. 4, 3, 2, 1. So they are rotation, translation, enlargement, and reflection. I think those are 4. But then in A level, you will learn 2 more, which is a stretch and a shear. These 2 are very much related to matrices. Don't judge me by my pronunciation. I haven't really searched on how to pronounce this. These 4, essentially you can use vectors to represent them, or even not. You can even just use your plain words. I mean, you can use plain words for both of them, but we're not gonna really focus on that, and we are going to continue with vectors and matrices. So first of all, we're going to talk about that later on in the video, but then now we first have to understand a vector. So a vector consists of vector have curly brackets. I mean, you can use square brackets, but then that probably just makes it a matrix of 2 by 1. So that's x, y. Remember, your x coordinates are always on the top for vectors. And unit matrices, an I, which is a unit vector in the direction of the x-axis, and j is the unit vector in the y-axis. So these are very common for representing in the Cartesian plane, especially when we have a j that direction and I that direction. You'll need to know these, very important. And now we're going to talk about transformations as matrices. So I'm gonna give you a quick example here. Here's 1, 0. It's the vector of what we're talking about, and as you have probably seen, it's essentially just a unit vector across the x-axis. So that's where I is. And if we multiply it by the matrix -1, 0, 0, -1, what will we get? Well, leave your answer in the comments. Pause the video first. And now we're gonna do this. So if we apply the multiplication rule, we'll actually see it's just equals to -1, which is here, I. Gonna add a comma there to indicate a change. And what can we say about the matrix? So the matrix essentially just reflects your current vector across the plane. When I say the matrix, I meant the -1, -1. And if this is a unit matrix, which is +1, +1, it will just stay the same, as we have discussed previously in the previous video. And same for j. If we have a, let's say, 0 and a 1 here, and that would just be where this is, which is j, and it will just reflect upon the x-axis, so j will be here. And now we're going to talk about the box method. Don't say it this way. I don't think the examiner will give you any points if you say this is the box method. If we have a figure, let's draw the plane here, and that is the current square, and that is a 1, 1 dimension. And if we have a new figure here, I'm gonna call that I, and that's gonna be I, the new I, and that's j, that's the new j. Let's say that's 3 and 3. So what we can essentially do is we can see from the figure that I, which is at the coordinate of 1, 0, is mapped onto the coordinate of 3, 0. So the image of I is essentially just 3, 0. Really interesting. And then for the j, we can see it's 3, 0, 2. So for this, oh sorry, it's 0, 3. Said it wrong because your y-axis is on the bottom. And then we can see that the matrix represents an enlargement sent to the origin. And therefore, what we can do is we can say it's multiplied by a matrix of 3, 0, 0, 3. We're putting the x first, always the x first. And if we do that for this 1, 0 and 0, 1, you'll realize they actually just turn into 3, 0 and 0, 3. It's really interesting, but then it works. And now we're going to talk about the main transformations we're going to learn in A level. So it's separately a stretch and a shear. So a stretch essentially is just your image stretched. So a stretch parallel to the x-axis will preserve all y coordinates, but changing the x coordinates by a scale factor k. So let's see. A stretch parallel to the x-axis. So x-axis, we can say that's here. We're gonna keep that as the original form, so it's more clear. So a stretch parallel to the x-axis will preserve all y coordinates. So all y coordinates will remain the same, but then changing the x coordinates by a scale factor of 2. So essentially, we're just moving one side or both sides by another factor. So we can change this into a more horizontally stretched shape, if that is a stretch parallel to the x-axis, and another stretch will be parallel to the y-axis, which we can see just goes higher. And it is similar to fx going to fx over k, as we have a more distinguished element replacing the x while the y always remains the same. And same here, we have a fx equals to a kfx because we are enlarging the y value of the graph, as we've learned in IGCSE. And now we're going to talk about shear. So a shear is when your lasagna, becomes slanted. So a shear with a fixed x-axis means the points of the x-axis remains the same, whereas all the other points will shift their x-coordinates. It may sound very similar to the previous stretch we've learned, but then it's quite different. Let me show you. So this is the original shape we started with, and a lasagna slanted will perhaps bring the first top layer to the other side and make it this way. So that is the new shape. And as we can see, it is very different because previously we remained the y coordinates while just filling in everything in its path. But then here we're actually moving the x coordinates, but then still connecting them with the other x coordinates. And a lasagna for the y-axis is just the same logic, perhaps something like this, while the x coordinates remain the same and the y coordinates alters. And a really interesting calculation for this is if we have the same scale, we will have a 1, 1, 0, 0. But then for a lasagna, in the stretch of the x-axis, we will have a scale factor of k over here. And that k is essentially just the m gradient of this line we're drawing. And the opposite, which is the lasagna over the y-axis, we just have 1k, 0, 1. Sorry, that's meant to be a 1 over there. And if we're having a enlargement alongside a lasagna, you can have two enlargement factors here, n. And that will be just 2 times the size, well, the same gradient. And let's see what we have more. And that's basically it. But then there are some other stuff you have to know. A reflection over the x-axis will be 1, 0, 0, negative 1. And if you have both negative ones, it will just be reflecting over the axis you're currently in. And then if you want to reflect over the y-axis, is negative 1, 1, 0, 0. Sorry, my Apple Pen ran out of battery for some reason. Okay. And rotation, anti-clockwise rotation. So this is a bit more interesting, but then you'll see. I'll show you. It's cosine theta, sine theta, negative sine theta, and cosine theta. So essentially what we're doing, if we're doing a 45-degree rotation, for example, if we have a 1 unit here and the 1 unit here, and we have a shape here, and if we rotate it by 45 degrees, let's see, anti-clockwise, then we have it here, and that's the new I, that's the new J. And according to the Pythagoras theorem, we know this is of length I, and this is 45 degrees. And how do we find this length? Well, 45 degrees is easy, but then we're going to use trigonometry. This is cosine. So cosine 45 degrees over 1. That's just going to give us root 2 over 2. And that's also root 2 over 2 because it's sine 45 degrees. And essentially what we're doing here is just cosine and sine, which is essentially what we're doing here. And then the same here, but then it's in the negative quadrant, so you know why it's negative sine. So that is essentially how rotation works. You find the new coordinates, and then you apply what we learned about matrices in there. And that is basically it. And always remember the stretches, the lasagnas, which is 1, 0, K1 and 1, K01 for a lasagna stretch of the same scale. And that is today. Thank you for watching, and make sure to leave a like and follow up for the next video.